Hey everyone. So we'll start the live stream, the actual presentation in 1 minute or so more people join. But anyways, hi, nice to meet you. I'm Omar, and Zach is here with me. He will also be presenting.
Hey everyone.
How are you today, Zach?
Oh, doing good. It feels like a Monday, even though it's Thursday. Okay, wow, it's been a week. How are you,
Yeah.
Omar?
I'm doing good, ending the day. Today was one of those days in which I spent quite a bit of time debugging weird issues in my code, but yeah, so the day went quite quickly.
Good. Yeah, I'm still dealing with one of those right now with the hub, so always fun.
Yeah. All right, what do you think that we get this started?
Sure, sounds great.
All right, so before kicking this off, let me explain what we are going to do today. So the idea is to show you what you can do with the Hugging Face Hub. We'll kick it off with like very basic things, and as we progress through this session, we'll show like very advanced like power user use cases, which can be quite interesting to you. If you don't know me, hi everyone, I'm Omar. I'm a machine learning engineer at Hugging Face. I don't know, Zach, would you like to introduce yourself?
Sure, absolutely. My name is Zach Mueller. I am also a machine learning engineer at Hugging Face. I just started around November, so I've only been here for a few months. But most of my work has been on the Hugging Face Hub, the little API library.
Awesome. So yeah, so I guess we can get this started. So at the beginning, I will present a bit, then Zach will continue the presentation, and then I will present you more things. All right. So if you don't know Hugging Face, like the Hugging Face Hub, it's a platform through which people can share and collaborate with ML models, datasets, and demos as well. So we'll get this just started, and this is how things look when you log in into your account. What I want to show first before any of this is models. I think models is probably like the most important thing. So Hugging Face has right now, as you can see, 28,000 models almost. Maybe by tomorrow there will be 28,000 models. And you can find models for many different things. So here at the left, you can see that there are tasks such as question answering, for example, text classification, and you can click here the plus 13, and you'll see that this is not only for NLP, for natural language processing, but also for things such as audio or computer vision, and even like structured data classification, so tabular data. So here you can see like all of the models sorted by most downloads. So let's go directly to this first one, which is GPT-2. So GPT-2 is actually like a quite famous model. It's for generation. And what you see here at the left is what we call model card. So model card is this concept that was proposed by Meg Mitchell and et al. And so there were like a couple of researchers in this idea. And it's pretty much a way of documenting what a model does. So for example, in this case, it says like what the model does. It explains some high-level description. Something that is quite important is the intended uses and limitations. And there are even like explanations on how to use this model. And there's like this limitation and biases. And it's quite flexible actually. So you can even add like explanation on how the model was trained, how it was evaluated, and things like that. By the way, feel free to ask any question in the chat. We'll have minutes to answer questions at the end. Sorry for the scrolling. So what's quite interesting is that here at the right, you have like this widget. So you can try out the model directly in the browser. So for example, with this input, my name is Mariama, my favorite. And what you get then is some text generated by the model, by the GPT-2 model. So my favorite character is her. And yeah, it's just generated text. And you can try this out with your own input. So for example, here there's another generated output, which is nice. And something that is cool about the hub is that everything is based in Git-based repositories. What that means is that you get files and versions control, and you can see like the history of this repository. So here you can see like all of the commits made here. So if you've used GitHub before, the workflow is quite similar. So you can git clone the repositories, work locally, and then do the git add, git commit, git push. You can even do things such as branches, merge. So it's the same kind of workflow, with the difference that here we have the management of large files. So in ML, many models can be like quite big. So here, for example, we have half gigabyte models, half gigabyte files, and there are repos with quite a bit more of data. So that's a bit harder to handle like in normal Git workflow. So here we use Git LFS. You don't need to worry that much about it, but pretty much we're able to handle like large files here, which by the way, like all of this is completely free. So maybe let's go and create a repo just to show you what you can do. So I will create here. I'm clicking here in my profile picture. I click new model. And here you can create any model you want. So I will call it just 1, 2, 3. You can specify a license. So I will pick this one. And the repo can be either public or private. So it's whatever you prefer. We have unlimited repos in both. So let me create this one. So at the beginning, you don't get anything, of course, which makes sense, except the license. And maybe what makes sense to show you first is the settings. So settings is actually quite self-explanatory. What you can do is change the visibility of the repo, so you can make it public or private. You can transfer, so if you need to rename it or if you want to transfer this repo to an organization, which we'll talk a bit more in some minutes from now, you can do that. And finally, you can delete the repository if that's something you want to do. Maybe let's go to the model card. So previously, I showed you a model card, but at the end, a model card is just a markdown file. So for example, here, I can write some stuff. This is a model card. So the model card is just markdown. So when you go back, here is the content. And as you can see here at the top, you get this tag. This is a link which you can use to filter for all models that have that specific license. In this case, this is a license filter. And that's specified here at the top in the metadata. So at the top, what you can do is add some YAM configuration that specify like some of the metadata. So for example, if you want to add some tags, I can here add, this is English, this is text classification, and this is, I don't know, a BERT model, things like this. So I just committed. This will show in the history. And here at the top, you can already see that this was labeled as text classification, EN for English, and BERT. So when you go here, what you can see is that actually at the right now, you already have this widget, which is actually quite nice, because by specifying this tag, the text classification tag, you automatically get the widget. Maybe let's go back to the GPT-2 just to show you what we had over there. So GPT-2 actually has a bunch of different filters. So for example, if you want to filter for TensorFlow or for PyTorch or for text generation or English, you can click any of this. And let's see how these are specified. So let's go to the README, and that's the nice thing about everything being open source, that you can just go and directly check out like the filters or the tags that people are using. So here you can see that they specified a language tag, expert tag, and the license, which is MIT. So where do these other tags come from? For example, TensorFlow or expert. So we actually automatically, based on the file extensions, can find quite a bit of things. So for example, if it's a TF model H5 file, we automatically detect that as a TensorFlow model or PyTorch model, or directly in the config for transformers, we can detect that this model type is GPT-2. So we try to make this as easy as possible and automatic for you. But in the case that you have like you want to specify some different things or some additional tags, you can always do that. So for example, what I realize now is that here in the README, the language was not specified with a tag. It was like with a separate argument in the YAM file. So we can go back to the repo I was working on, which is this one. And here, what I did before was wrong. Like I just put it in the text, which is not the right way to do it. You can do it like this. And here we go. Like now we do have like a language tag that you can use to filter. So let's go and explore a bit what filtering is. So for example, let's say that I want to see all of the text classification models in Hugging Face. You can see that there are like 2,800 models for text classification. And here I can even write like sentiment. And now I find that there are like 216 models that have sentiment. So it's probably like sentiment analysis models. But as I was sharing before, this is not limited to NLP. So for example, if I want to check out like some, I don't know, text to speech. So text to speech is you receive text, it generates a speech. You can find 160 models, which again, these are open source and you can try it out directly here in the widgets. So for example, here I wrote, hello, this is a test run. And here it generates an audio that you can play. You cannot hear it, but you get the idea. And again, this is not limited just to by task. So for example, let's say that I want to find a model for Spanish. So we have now 428 Spanish models. And let's say that I'm interested in translation. So now I see that there are 218 models, many of them by the Helsinki NLP group, which are for translating either from Spanish to another language or from another language to Spanish. By the way, in the case that you would like to learn more about how to create like good model cards, I would suggest you to check the course. So in the course, the Hugging Face course, which is free again, so you can go there by clicking this burger icon and here in community course, we have a section focused completely in which are like good practices for good model cards. So it suggests you like some of sections that you should add with some examples of good model cards, some notes on the metadata, and yeah. One last thing I wanted to show you related to the basic usage of model repos is that you can upload Tensorboard traces, and it doesn't matter if you are working in any library. If you upload to any repo like Tensorboard traces, you get automatic free hosting of Tensorboard. So for example, this is for Big Science, which is a research project at Hugging Face, and they upload here the logs for Tensorboard. So it automatically gives you like this tab, which is training metrics. It takes a bit because in this case, if I recall correctly, they have a lot of logs. So we'll need to wait a bit, but it will automatically generate this free Tensorboard hosting, which is quite cool. All right, let me quickly check if there are any questions, and it seems there are no questions. So let me show you like a couple of quick last things. So let me go back to the model I was working on, which was this one. And let's say that it was automatically detected as a task that was not the one I was intending to. So what you can do is override any automatic decision. So even if we try to do things automatically, sometimes we can get things wrong. So you can override anything that we do by writing here pipeline tag. And I can put here like text classification, for example, which I wrote incorrectly. It should have been like this. And then you override any automatic thing. But maybe you then realize that here we automatically suggest like some default example. And you as a user, like maybe like your model is like for a very specific kind of input, and you want to specify like some examples, default examples. So this is an example, and pretty much what I do is in the widget value, you can specify a title and a text, an input, let's say, for every example that you want. So here I added two examples. One that says, my name is Omar in Spanish, and another one that says another test. So when you commit this, here at the top right, so you already get one of these. But here at the top right, you can click examples, and you can see that it says example 1 and test, which were the two tests that we were working on before. This is even not limited just to text. So for example, this one is a, let me check if this is a good example. This one is a speech example. And here they have like an audio file as an example. So let's just go and see how they do it. So we can go to the README. And they do like something extremely similar, right? So they put example, title, common voice sample one, and here is the source. So here is the link to this exact sample. Maybe one other thing that is cool is that at Hugging Face we have like this use in transformers, for example. So if you're in GPT-2 or in the Helsinki, you have like this using transformers, which you can click. And it gives you like a code snippet that you can just copy and go directly and test it out in a Colab notebook. And it also gives you like a snippet to clone this repo and work locally. And even it has this link, read model documentation, that takes you to the documentation of that concrete demo. All right. Let me see if there was anything else I wanted to show you about this. Okay, so one last thing I will show you related to models is how to do filtering for libraries. So many people know about transformers at Hugging Face, but something that many people don't know is that we actually have use cases for third-party libraries. So we build collaborations with other libraries such as Spacey, Sentence Transformers, SpeechBrain, Stable Baseline Tree for reinforcement learning, FairSec, and you can filter for this. So you can go to Spacey. You can go here, for example, for this English example from Spacey. You can click compute and you get like direct inference here. And you can even click here using Spacey. And you get a widget of how to use this model specifically in that library, which is actually quite nice. And if you see here at the bottom right, you get like some evaluation results. This is a way in which people, like users, can self-report metrics on their model, which is also added in the metadata. So here in the README, the model card, you can find like these metrics, which are self-reported. And we actually already add these metrics automatically when you use the Hugging Face Transformer trainer, but you can also use this for other libraries. And actually here at the bottom left, you can filter to get all of the models that have these eval results. Let's go for this one. And here we have again like the evaluation results. But what is quite cool is that we get this view leaderboard link, which is an integration with Papers with Code. So here you get all of the models that were evaluated on this same dataset, and you get like this nice leaderboard. And you can click any of this. So for example, let's go to this one. And it will take me back to Hugging Face to the repo that had this concrete self-reported metric. And yeah, just to finalize this, maybe like one thing that is cool as well is that if you use SageMaker, you can click here, train, and you get like this easy way in which you can fine-tune models or train models or deploy them if you want to deploy them. And we also have like the inference API, and it pretty much allows you to do like basic HTTP requests that you can make any like calls. So it can be JavaScript, Python, Core, like whatever library language you want to use to make inference. So this same thing as in the widgets, you can make HTTP requests and test out or integrate those very easily with your product. So if it's an Android app, for example, or if it's a more complex thing, you can also do that. All right. That's everything I wanted to talk about models. Let me just give like a 2-minute overview of datasets. But datasets have pretty much the same story. So we have datasets which are also Git-based repositories. And you can do similar things such as filtering by language, by task, by categories, even by size or by license. If you click one dataset, you also get like something similar to a model card, which is called a dataset card. And you can even explore the dataset a bit in the browser. So for example, here you get like some examples of this dataset. And here at the top right, you get like this use in dataset library, which gives you a code snippet in how to use this with the open source datasets library. At the at the right, you can see like which models were trained with this model with this dataset, sorry, which is quite cool. So you get like models linked with datasets, linked with spaces, which we'll talk a bit later. And let's go just to this model just to see what this means. So here, for example, this model was trained or fine-tuned with glue and multi-NLA. And how this is detected is, again, everything goes to the metadata. So in the metadata of the models, users can specify which are the two datasets that were used. All right, I think that was everything I wanted to talk about models. Let me bring back Zach. Hey, Zach.
Hey, there we go.
Hey, yeah. So I don't know if you would like to present now.
Sure, yeah, we can do that. Let me go ahead and share my screen.
Sure.
Perfect. So yell at me if for some reason it doesn't look good, but I think I can see it. So piggybacking off of what Omar just presented, we're now going to look at the Hugging Face Hub library, which is a Python interface for you to do everything he just showed you without having to go to the website. Instead, you can just do it in your Python interface, be it Jupyter or whatever. So this is the Hugging Face Hub library. You just do pip install Hugging Face Hub. And then we're going to import a few helpful classes from the Hugging Face Hub. The Hugging Face API, the model filter, and the model search arguments. Since so far, we've just looked at models. Now let's propose a few situations. I want to be able to find a text classification model that was trained on the glue dataset, and I'm working in PyTorch, so I want it to work in PyTorch as well. How would we frame this? Before we do anything, we need to make sure we can communicate with the API. So we're going to instantiate this Hugging Face API class here, and I'll zoom in a little bit so folks can see a little better. And next, I want to be able to know what I can search by. So we're going to create a model args that's going to be our model search argument. Now, these model search arguments will go through all of the models that we have that are shown publicly, and will give us everything we can search for in a nice exploratory fashion. So if I just look at model args here, we can see that it'll tell me we have these available attributes or keys that we can search for: author, dataset, language, library, and so forth. So the first one we want to look at was text classification, right? Well, pipeline tag is what we basically call tasks in this case. So if I go over to pipeline tag and I press tab, this will give me autocomplete. And what we find is there's text classification right there. And what this will basically do now is if I say hit enter, we'll get this helpful little string back that says text classification. This is what the API knows to read, whereas this fancy nested object is a nice way for you to go and search through what's valid without having to memorize every little thing. So let's continue on, and you'll see why this quickly becomes useful. The next one we wanted was trained on the glue dataset. So we'll do model args.dataset, would make the most sense. And then we'll look for glue. And there it is. Now, if we look at it, we have this special dataset : glue. So here we get to a case where it's not really one-to-one what you'd expect when I'm, say, about to go search the hub and give it a query. And that's really why the model search arguments are very powerful and useful for you, because even if you just want to know what to search for, you don't have to sit there and struggle for hours. Instead, you just go and explore this nested dictionary object to go and find it. Now, the last thing we wanted was it needs to be compatible with PyTorch. So if we do model args, and then if we look, we have this library attribute. And then this goes through all those third-party libraries that Omar talked about earlier. Right at the top, for me, is PyTorch. Now that we have all of this, how do I say go and find our model? So we take all of this and combine it into the list models function, which will go through and query all of our hosted models and find anything that matches. So we're going to say, I want a filter that uses this pipeline tag. Filter equals. We want it to use our data set that we had. And finally, we want it to use the PyTorch library. And now when I hit enter, we get back a bunch of different models, like I think over 100, hosted on the Hugging Face Hub that match our requirements. So here we have this first one. It's the XLM Roberta Large IT M1I model. And so now, without having to necessarily leave my workspace, I can go through and find a particular model for the task I'm trying to do. So let's see how complicated we can get with this, though. Let's propose a new one where I want to be able to find all token tagging or NER models that are for the French language that are compatible with both PyTorch and TensorFlow. So similar to before, we're going to write a model filter. And here, it's going to look a little differently. So we'll say, we're going to use the model filter class, which the model filter basically lets us write our REST API call, like all this fancy stuff we had in parentheses here, but wraps it in such a way that complex queries are easy to read and perform. So for example, I'll do model filter, language. I'll set that to model args.language. And then we want French. And since we're using the two-letter acronyms, that'll be FR. And then the task, in our case, is token classification. So we'll do model args.pipeline tag.token classification. Eventually. There we go. And then finally, we want to be able to say, I want to use two libraries. So we'll say library equals, and then I'll put a little parenthesis around it, and we'll say model args.library.pytorch and model args.library.tensorflow. So this now takes that pretty complex query and writes it in a clean and organized fashion. Also, if you do know what all of these are, you don't have to use the model args. So for example, I could rewrite our library as library equals PyTorch TensorFlow, rather than this very long, basically this very long chain. But that's only if you know what you're actually looking for. All right, so now we have our model filter. Let's search for the model. So we'll do api.list models filter. We should find only about 1 or 2 models now that fit our very specific query. And so now with this, if you can't quite find the model you want using the web interface, you have very specific requirements, you can instead use this functional API to go and find any particular model that you need, especially if it has very niche requirements. So that is pretty much what I had for the models. So let's go see what we have question-wise. Are there any? Awesome. It doesn't look like there's any. So Omar, you can magically pop back on if you would like.
Awesome. Actually, I want to talk more about datasets. I don't know if you would like to also present about datasets, no?
Yeah, absolutely. We can do the same thing for datasets afterwards if you'd like.
Sure. Sure, sounds good. Right, so let me present. So I will talk a bit about Spaces now. So if you haven't heard about Spaces, it's pretty much a very nice way in which people can create and host ML demos. So for example, if you want to build your portfolio, if you want to collaborate, or if you need to showcase this to stakeholders, it's like a very nice tool to create demos that you can show to other people. And what we support is open source libraries such as Streamlit and Gradio, but nowadays we also support static spaces, which would be like HTML and JavaScript like, or even like Bokeh or TensorFlow.js and more like a custom, even like, I don't know, Fast API or Flask kind of use cases. There are actually like, this is extremely updated. It says 200 spaces. Nowadays we have around 2000 spaces. And it's pretty cool. Like you can explore these demos created by the community. So for example, here, this is a demo. Again, everything is open source. It takes about a minute. So this one won't be like a good example for now. Or actually it took 6 seconds. But this is like an example for denoising. So what it does is that it removes the noise of the image at the left. And it's nice because you can go files and versions and again, like see all of the history. Again, like this is open source. We try to highlight like some cool demos created every week, but you can just go out there and explore over 2000 demos by the community. What might make sense now is actually to create a space, just to show you like what's the usual workflow. So you can go here, click new space. Let me just test demo. Again, you can specify a license. And you can specify like what SDK you want. So I will go with radio right now, but you can use any of this. You can again do it public or private. And here, when you begin, you get this link to the documentation, and you get like some instructions on how to do it. So what it's suggesting is to git clone this repository, create a app by file with this content, and then again do git add, git commit, git push. It even has like some additional tips, but you can also do all of this directly in the browser. So first, I will just copy this code, and I will explain it in a few minutes. But what the tutorial said was to just create a app.py file. Let's paste this. At the beginning, it says it's building. Actually, we can click here, see logs. And in the logs, you can see like what's happening back there. So if ever like one of your spaces breaks, this is like a very easy way to debug what's going on. So now it's running. We can go here. The first time it always takes a bit longer because it's the first time it's being set up. So again, let's look at the log. So it seems now it's running, and here we can write something, and here we get the output. So this is a radio space. It's very nice because you get like a very nice inputs, outputs interface. So you can get here like very nice titles, descriptions, links to the paper, to the GitHub repo with the original code. You can take screenshots. And let's go to the actual code. So this was like a very non-ML case. This was just like a hello world example. But what Graded does is that you usually have like a interface which has a function that processes an input, which in this case was a text input, and outputs another thing, which is the output of that function, which in this case, again, it's text. Let me show you like maybe a more interesting example. I'm just copy pasting right now from another place. And this is using transformers, but again, you can use like any library that you want to use. So if you are a TensorFlow user, you can use this. What you can do is with the pipeline class, here I'm loading a translation model from Helsinki, which is an English to Spanish one. Here I have like a processing function. Don't worry about what's in there. Pretty much the idea is that it takes an input, it does some processing, and it has an output. And finally, there's the interface. So it specifies like what's the function, which is the input, which is the output, which is the title, and some examples even. So let me click commit changes. And what will happen in a few seconds, it's still building, is that it will fail, or I expect it will fail. So we got runtime error. So it's complaining that we don't have transformers in here. And that's because as a user, you can specify whatever libraries you want. And you can do this with a file called requirements. And for example, here I might want to have, let's say, transformers, sentence piece, and storage. I think these are like the three libraries that we want. So when every time you commit, it will automatically kick off like a rebuild of the entire system, which is quite nice. And in this case, since it needs to pip install all of this the first time, it will take quite a bit. So here you can track in the logs like how the process is going. So right now it's downloading some files from the hub. So it's already downloading the model. And here we go. So just with those like 10 lines of code, we got this interactive demo, which has like a nice title. Here you can click like the examples. You can click submit. Here you have the output, and you can take a screenshot that will automatically be downloaded, and you can share in social media if that's something you want to do. Something that is very cool is that here at the top right, you get this link which says linked models. So when you click here, you actually automatically we detect which is the model that is linked to this space. So I can click it, and here I'm back to this model. And here again, like you get a list of all of the spaces that are using this. So for example, here there is a space that we are working on. So we are back here. Something that might be interesting for some of you is that you might want to use a private model, or you might want to make some calls to some server or some API, and you don't want to expose your password or your tokens. So you can go to settings, and we have this thing which are called secrets. And the idea is quite straightforward. You can create here like I don't know, let me put a better name. So token, for example. And here you can put like any value. You can click add. And now there is like this repo secret that you can access from the code as an environment variable in the case of Creditio, which is quite nice because now you can access like things without exposing those to the users. So if you want to use any API, if you need to make any calls to a custom server, you can use this. If your space is ever broken, you can also like restart the space. But apart from that, like all of the other settings are pretty much the same as models, or as models. One other thing, and that might be interesting for people that are using the Hugging Face Hub library, which is what Zach was showing you before, is that you might want to use it with private models, or you might want to, so he showed you how to filter models, but you can also create repositories and upload files. And if you want to do that, you need to have a token. So here you can go to settings, and you can go to access tokens. And what is very nice is that you can create user access tokens. So for example, if I click here, new token, it can be a read or a write token. So let's say I want a write token, and this will be for blog. You can generate a token which you can copy, or you can refresh if you want, and you can use that directly outside Hugging Face to make calls to your models that are in Hugging Face. And it's very nice that you can create many tokens, because then if one of them are exposed, you don't need to change all of them. So the good practice is to have like one token for each use case. So if you have a blog and a server and also some GitHub Actions workflow that syncs your GitHub repo with your space, you can have like one token for each of these, which is quite nice. One last thing I would like to show you is organizations. So you can go here and click new organization. And I will create an organization called Llamas, which might be taken, I don't know. Seems like it's not. So it's an organization, and something that I like quite a bit is, going a step back, so our organization is pretty much a group of people. So you can have like organization models and datasets and spaces. So let me go, for example, to Carrots.io. So Carrots.io is this organization in which a group of people from the community are creating Keras examples, models, and datasets. So this is like a very nice community collaboration. So going back to the settings, you can do a bunch of stuff. So adding a logo, a website, you can add members, and you can even give like different roles. So write, read, or admin to different members. You can have billing, API tokens, and different kind of stuff. And something I like quite a bit is that you can specify a org domain name. So for example, if you're using this in your research group or in your company, all of you might have an email which is, I don't know, something like this, right? So this, for example, is my domain name, but for your company, you might have like a, I don't know, company.co. So you might want to automatically add people or offer this option to automatically join the organization. So actually, what is very nice is that if you specify this domain name and you configure this, when other people with the same email sign in, they will get like some nudge to join this. So you will get something like this, and here you will automatically get like this option saying like, hey, we suggest you to ask to join this organization. And that's like a very nice way because if you're a research group and you do have like 100 people and you don't want to, you want like a very easy, straightforward way for people to join. This is like a nice way, which is also secure, and it's a good way to collaborate in your company or research group. All right. I think that's it from my side. Let me bring Zach back again to show you more cool stuff about the Hugging Face Hub library.
Sure, yeah, we can take a look at some fun things. So I'll go ahead and share my screen then for a moment.
Sure.
There we go. All right, so similar to how we could search models, right, with that functional API, we can also do something similar for any sort of data sets that we might want. So for example, let's propose another little situation where I'm interested in trying to find models that pretty much can be used with the Raft benchmark, and specifically and data sets that are valid within this sort of benchmark. And what we can do is by using the functional API, we can go through and search for any of those data sets. Now, very similar to the model search arguments and model filter from earlier, we have the dataset search arguments and the dataset filter that operate exactly the same way. So we'll make some dataset args. And similarly to before, we get this sort of exploratory process with tab completion that tells us what all we can search for. Now, the first thing that I wanted to look for, and actually I'm going to partially change that. This is a typo. This should be superb data set. Is I want to look for the benchmark, right? That superb benchmark that we're doing now. So we have benchmark as an available key. So if we do benchmark, and then I look, there's superb, or the superb data set. And here's another case where knowing what these dataset search arguments is really important, because here we have this special benchmark colon and then our superb data set. Okay. And the next requirement that we want is we want the one specifically by Luton. So if we look down here at dataset args again, we find author, and then we can look for Luton. And there it is. Now here, because author isn't necessarily part of the regular API call, we're just going to go ahead and directly use the dataset filter. So I'm going to say filter equals dataset filter, benchmark equals our dataset args benchmark superb, and then our author is dataset args author. And now if I list our data sets similarly to our models, we'll find the two data sets that so far support that query, which in our case, I'm more interested in this one than the predictions test. Now, let's try and get a bit more complex with this. I want to find all data sets that contain both English and French whose annotations were crowdsourced, and my task is, say, conditional text generation. That's a very specific, very niche query that we're trying to do. So let's see if we can find that. So here I'll use the dataset filter again. And rather than using the search argument, I'm going to go ahead and just use the raw strings here because we sort of already talked about what most of these look like. So I'm going to say languages. And we're going to say the 2-letter characters for each of the languages. So we're going to say French and English. Now we're going to say language creators. And I want this to be crowdsourced. It's just the raw string as we would expect it to be. And then the task categories, we want to be conditional text generation. That basically is one-to-one what we asked earlier. So now if I do API list datasets and look at the first result, make sure I spelled that right. That should be crowdsourced. Here we go. You can see that we find the Opus Parcus dataset by Gem. And this fits everything we wanted. The annotations are expert generated as well as machine generated. There's a few other tags in there, but it's also, here we go. We have our languages off to the right here, as well as the, somewhere all the way in the back here should be the task categories. So with this functional API, you can very quickly go and find any sort of data set that you might want to train on that you potentially would want to just start and play with a model, for instance, rather than necessarily having a task where you know exactly what you want to do. You can use this to go explore what can I train to, say, fit this particular criteria. And that is the functional searching API for datasets.
All right, thanks a lot. So I think we're pretty much done. There were like one last thing we would like to show you is this activity feed. So it's pretty much like a place where you can see like the changes you've been doing as a user, and at the right you can see like what's trending out there. So if you want to see like which models are being liked quite a bit lately, or datasets or spaces, and you want just to try them out, you can go here. You can also like give them a like. If you like them, of course. And yeah, that's pretty much everything we wanted to show you. Please feel free to ask us any questions in the chat. We can answer like a few questions, although I think we only have one. But yeah, let's go to the only question. So the question right now is from Jonathan, is if I want to use the model such as GPT-2 or T5 and deploy it to ONNX, or some kind of model file, does the hub tells the size of the model and the required CPU memory size? No, we don't at the moment. We might have this in the future. It's also a bit complicated because it's dependent on what framework you are using, right? So if you go to GPT-2, here you can already see like a TensorFlow model weighs 475 megabytes, but the PyTorch model weighs 523. And then CPU memory size, yeah, it's a bit more complicated. Something you can also do, by the way, since we are having like more ONNX models, is we have a filter for this and expect this to increase in the future. And here you can know like which repos on the hub already have one of these files. And yeah, all right. It seems we don't have any other questions, so I think we can wrap it up for today. What do you think, Zach?
Yeah, that sounds like a plan. Thank you guys so
All right.
much for joining us today. It was a lot of fun, and I hope you learned a few things about Hugging Face, the model API, the dataset API, and spaces.
Maybe one question that people might have is like, when would they like to use like this Hugging Face Hub programmatic API instead of using like the browser?
Sure, yeah. Personally, it's a preference idea in my head. Usually, if there's some very complex search argument you want, such as what I showed earlier, it's a lot easier to do with the functional API rather than the website for right now. The other case would be you just want to keep everything in your workspace and you don't want to have to jump between tabs. You can just have everything there and don't necessarily mess with your flow. In my opinion, it's pretty much what you're comfortable with. We give you these options so that way whatever is the most efficient for you, you can absolutely just go and have at it. But I would not necessarily say one is better than the other. They each have their benefits and their complexities and their limitations. There we go.
Thanks a lot. Yeah, so in case anyone is interested on this, like this is open source, so you can go just here to Hugging Face Hub. Please leave a star. Just to add a bit to Zach's answer, we also have like integrations with third-party libraries. So if you go to in our documentation, we have like this page which says like which are the different libraries that we have integrated, and these are completely based on this library. So if you need like programmatic creation or access to repositories, using the Hugging Face Hub library is like quite powerful way to do it. But if you don't want to use even Python, like all of our endpoints are open and documented for you to do, for you to use. So if you want to integrate this to some other kind of service, you can also do it if you want to go a bit more hardcore way. All right. Okay, yeah, I think we can wrap it up now.
Perfect.
Thanks a lot, everyone, for joining. Thanks a lot, Zach, for joining as well. And have a great day.
Have a good day, everyone.
See you.